Hello everybody. So, second video here. This one on right cylinders. Um, right cylinders are 3D shapes that have two circles as bases, rectangle connecting them. Just one rectangle, kind of wrapping in on itself. You'll notice that there are a few things pointed out here. We have the circumference equation, which is going to come into play. We have the base, capital B for the base, which is pi r squared. That's the area formula for a circle, as we learned earlier. And we also have the height of the cylinder, the distance between those two circular bases. And these are all going to come into play with surface area and volume. So, before we talk about surface area, let's draw the net of this. What we're going to have is we're going to have a circle. That can be the top circle. And then, sort of coming off of it, we have this rectangle. And we'll talk about how the rectangle forms and how we see that playing out in the surface area equation. And then, we have another circle that should be the same size as the first circle that we drew. And that's what the 2D unfolding of a cylinder would look like. Now, based on that, you'll see in the surface, well, if we're doing the surface area, we're going to need to find the areas of two circles. And each of those circles has a radius. So, the formula for one of those circles' areas is going to be pi r squared, but we need two of the circles, so we're just going to take that number and multiply by 2. So the first part of our equation, and a lot of you may have realized this already, is going to be 2 pi r squared to get those two circles in there. So let's draw our attention now to the surrounding part. This part and all of this. Everything on both sides of this part of it. So one of the dimensions on the rectangle should be pretty easy to see, and that's going to be the height. And I'll label that on our net. That's the distance going up and down, of that rectangle. So that one shouldn't be too much of a stretch. But that leaves the question of what is this length then? And the answer to that question is, think about the fact that we're taking our circle up here and we're basically unwrapping it to get this rectangle. What that would mean is that this segment here is the distance around the circle, the perimeter of the circle, if you will, which we have a special name for, which is circumference. So, that top dimension of that rectangle is the circumference, 2 pi r, which means that the area of the rectangle is 2 pi r times h, the height of the cylinder. And when you combine those parts together, you have the surface area of the cylinder. Volume is a little bit easier. It works just the same way as prisms. You'll need the area of the base, and then you'll multiply it by the height of the cylinder. So we're going to have pi r squared times h, and that's all you have to do for the volume. So those are the formulas themselves. Let's apply them a little bit. All right, so our first example. Find the height of the right cylinder if its surface area is 157.08 square meters. 157.08. Okay, so this is going to be one of those work backwards problems. So let's start on that then. So we'll be able to plug in the fact that we know the radius is 2.5 meters. The first part of our equation is 2 pi r squared. So that's going to be 2 pi times 2.5 squared, plus the second part of it is the circumference times the height. So the circumference here is going to be 2 pi times 2.5 h. And our goal in the end is going to be to find h. So let's clear some of these numbers up by doing a little bit of multiplication, make things a little bit nicer for ourselves. First of all, we should probably figure out what 2 pi times 2.5 squared is. So this is where your calculator will come in handy. And I end up getting about 39.25 for that. I use 3.14 for pi. Plus, let's figure out what 2 times pi times 2.5 is. So we get 15.7h equals, and we still have 157.08 over here. Next step I would recommend would be to subtract 39.25 from both sides of the equal sign. 157.08 minus 39.25. So we have 117.83 equals 15.7h. And now we'll just divide both sides by 15.7. By 15.7. And we get that h is about equal to 7.5 meters. So there's that problem. Moving over to the other side of the sheet. Here, we are asked to find the volume of this solid. So we have the radius, we have the height. Our volume formula, remember, is pi r squared times h. So here, we're going to have pi times 9 squared times 6, which is our height. So 3.14 times 81 times 6. So the volume here would be about 1,526.04 feet cubed. Notice that it's feet cubed because we're dealing with volume. If we'd been finding surface area, we would have had feet squared. All right. You are wrapping a stack of 20 compact discs using shrink wrap. Each disc is cylindrical with a height of 1.2 millimeters and a radius of 60 millimeters. What is the minimum amount of shrink wrap needed to cover the stack of 20 discs? Well, when we're talking about covering something, cover is more a volume, or more a measure, of surface area than it is of volume. Because we're talking about how much we need to cover the surface of the disk. So we're told that the radius is 60 millimeters, and we're told that h is 1.2 millimeters. And this is all the information we should need to find the surface area of one disk. To find that, we're going to use the surface area equation, which again is 2 pi. It's basically 2 times the area of the circle, so that would be pi times 60 squared plus the circumference times the height. 2 pi times 60 times 1.2. So let's just enter that all in at once. 2 times 3.14 times 60 squared plus 2 times 3.14 times 60 times 1.2. And what you end up figuring out is that the surface area of one of these discs is 23,060 millimeters squared. Now keep in mind, millimeters are very small, so to get a square millimeter, that does not take up very much space whatsoever. It's actually a very small unit of measure. Now this is the area of one disk, but we need 20 disks wrapped. So all we have to do now is multiply this answer by 20, and we find out that it would take 461,203.2 millimeters squared of wrap to cover those CDs. Now, if you were doing this calculation in reality, you might want to use a different unit from millimeters. It's going to mean that you are using, you're going to be using, your answers are going to be smaller basically, but that is not necessarily a bad thing. All right, so that wraps up this video. Hopefully you learned about cylinders and sort of some of the calculations that you can do with them. And I will see you in the next video.